Hi friends, here is a nice problem. We have A, B, C, D, E, F, G, H, which is a regular octagon. What is a regular octagon? Regular means the length of all sides is equal. For example, regular triangle means equilateral triangle. A and E are opposite vertices of the octagon. A frog starts jumping from vertex to vertex beginning from A. From any vertex of the octagon except E, it may jump to either of the two adjacent vertices. For example, if this is some regular octagon, except E, E is opposite to A, everywhere it can jump to the left or to the right. From B, it can jump to A or to from C, it can jump to B or to D. From D, it can jump to C or E, but from E, it cannot jump anywhere. It has to stop at E. It may jump to either of the two adjacent vertices. Right. Let A and B the number of distinct paths of exactly n jumps ending in E. For example, taking 50 steps, how many such 50 steps routes are there to E? For example, if n is 50, what does that mean? It can go here like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever. Right, taking 50 steps, you can go in circles, you can come back, you can go forward, whatever. Right, it can go till D and then go back till F and then come back till D, whatever. Right, because once D, if it goes to E, it cannot come back. Right, that is the final step. So, in such 50 steps, right, coming till here, then going back, then again coming till here, or going back, whatever. Finally, reaching E. If that is 50, if n is 50, there are how many ways? Let's say 50 steps, there are, let's say, 20 ways. Then, what is the value of a 2n minus 1? 2n minus 1 means when n is 50, there are 50 steps that we need. Then, what is the number of ways? And what is the number of ways when 50 into 2 minus 1? When we need 99 steps. Right. In 50 steps, if it is 20 ways, in 99 steps, what is it? This is the problem. Right. Now, this looks a big problem, but in fact, it's a very straightforward problem. There is a small hint here. There is a regular octagon, means eight sides. At the same time, A and E are opposite. Let us use these things. A and E are opposite. And then and A 2n minus 1. If n is any number, 2n minus 1 will always be odd number, right? 2n minus 1, 2n plus 1 will always be odd. N can be even or odd. Right. Let us use these hints. Let us look at this regular octagon A, B, C, D, E, F, G, H. Now, let us say from A, how many ways are there to go to B? Right, A can go to B, or it can go from A, B, then C to B, or A, H, A, B, whatever. Right. Now, if you see A to B, A is next to B. That means A to B it takes one step. The minimum it takes one step. Right? A to B minimum it takes one step. Is there any way from A to reach B in two steps? B is immediately next to A, right? Is there any way? Because first step it takes here, second step either it will go here or it will come here. So if it goes towards B, in second two steps there is no way it will reach B because in two steps either it will reach C or it will reach A. Similarly, if it goes this side in two steps, either it will reach G or it will reach A. There is no way it can reach B in two steps. A to B one step is possible. Two steps not possible. Right. Similarly, A to A, A to A, A to itself. In one step, is it possible? Because one step it will either move this side or this side. It will either reach H or B. There is no way in one step A can reach itself. In two steps, it can reach itself, right? A to B and B to A. First step like this, second step like this, or first step like this, second step like this. In two steps, it can reach itself. But there is no way in two steps it can reach B or H. Right. Now, if you see, B is one step away from A. So there is no way to reach B from A in two steps. Similarly, C is two steps away from A. Right. So is there any way we can reach C in three steps? See, C is two steps away, which is even number of steps away from A. Is there any way we can reach C in three steps? If you take one, then two, three will go to D. If you one, then two, and three it will go to H. Right. One, two. There is only two steps, right? If once you move, you will take one more step, it will either move to D or to B, or if it go this side, A to H, one, two, three, then you can reach B only, right? So you can see if A we take a 0, in even number of steps, we can reach all the even positions, including A itself. Even steps. If I got, for example, two steps, one, two, it can reach A. One, two, it can reach C. One, two, three, four, it can reach E. It can reach E. Right. Similarly, odd number of steps, it can reach H. H or uh, odd number of vertices. Right. There is no way with an odd number of vertices, odd number of steps, it will reach an even vertex, or even number of steps, it will reach an odd vertex. For example, two steps, there is no way to reach B. Now here, what is the question? The question that is given is A 2n minus 1. 2n minus 1 is always odd. Right. Whatever is n is even or odd doesn't matter. 2n minus 1 is always even. Here E is 2n minus 1 is always odd, right? 2n is always even. E is even number of steps away from A. Whatever you do, there is no way to reach E in odd number of steps, right? E is how many? 4 steps away from E, which is even number. E is evenly away from A, right? Distance between A and E is even. So with the odd number of steps, we cannot reach E. That is what here it is given. Whether it is 99 or 1009, whatever odd number of steps, whatever you take, you cannot reach E. You can either reach D or F or H or B, but not E. That is the problem about it. Right, guys? It's just a verbose problem. It looks lengthy, but it's pretty straightforward problem.